Hi everyone, this is a video trying to illustrate the proper way to do a factorial ANOVA in SPSS. So as we went over in class, factorial ANOVA is just like any other ANOVA is going to require certain types of data. So for the factorial ANOVA, you need at least two independent variables, and those independent variables need to be nominal in nature. So the scale needs to be nominal, categorical, something like that. So we've got three different types of nominal variables here. Year is really, it's basically a ratio scale or interval scale, if nothing else. You can think of it sort of as being nominal depending on what you're analyzing, but for us it's going to be not one of those. So these are the nominal variables, and those are possible independent variables. Now for the dependent, you need scale variables, so something that's interval or ratio. And then over here we've got several of those. These data, by the way, are election data by election year and by state and all of that. So we've got 51 data points for each election year, the 50 states plus the District of Columbia. You've got Democratic votes, that's the total number of votes cast for Democrats in that particular state, then Republican votes. You've got percentage of the vote for Democrat, Republican. These are not necessarily going to add up to 100 because you might have an independent candidate who takes away some of the percentage of the vote, so it's not going to equal 100 here. You've got the debt to gross domestic product ratio and then the unemployment rate. And this is the unemployment rate in October prior to the election in 1980, which would have happened in November. So we've got all of these data. You've got the state, this is the region, as dictated by the U.S. Census Bureau, I believe. And then what I've done to minimize the number of levels of this variable, because there are 9 different elections here, I believe, what I've done is I've categorized that into presidencies. So we've got 5 different presidency timelines here. So 1980 and 1984 are the Reagan years. 1988 is Bush Sr., so George H.W. Bush. 92 and 96 are Clinton. 2000, 2004 are George W. Bush. And then obviously 2008 and 2012 are Barack Obama. So let's say that I'm interested in creating some model that dictates that presidency and region are predicting percentage of the Democratic vote. So percentage of the total vote that went to Democrats. And we're looking at presidency here sort of as a timeline. So Reagan being the furthest back and Barack Obama being the most recent. So has Democratic percentage of the vote changed over time? It's possible. Also, does percentage of the vote depend on the region of the country? Do certain regions, for example, like the Midwest or the South, on average, vote more for Democrats or for Republicans than maybe the West and the Northeast? So that's a model we could come up with. It could be that Democratic percentage of the vote varies as a function of presidential term, region of the country, and perhaps some interaction between those two. So if we wanted to run this, we would click on Analyze, General Linear Model, Univariate. Now the dependent variable is exactly what it sounds like. It's going to be Democrat percentage of the vote. We'll bring that over. Fixed factors, remember, those are the independent variables for right now. So we're going to bring over a year. This is our presidential variable right here. And then region of the country. Now, if you click on Model, it's going to bring up this dialog box, and it's not necessarily something we need to work on right now. Again, I mentioned in class that the default is the full factorial, which means that the model is automatically going to be all of the possible main effects and all of the possible interactions. So it's going to build everything. We're going to keep it that way right now, so just click Continue, neglect that. We're also going to neglect contrasts and post hoc for the moment. We're going to click on Plots, so we can get a graphical representation of what we're looking at. Since we're thinking of year here and presidential term as a time component, we'll go ahead and put that on the horizontal or x-axis. So as we go to the left on the graph, it's going to be going further back in time, and as we go to the right, it's going to be more recent in history. And then the different lines, different color lines, are going to be representing different regions of the country. So we'll add that, click continue. Now if we click on options here, the things we want to focus on are the descriptive statistics, so things like standard deviation, mean, and also the estimates of effect size. So this is going to give us our partial eta squared. And for right now, we'll just select all of these, bring them over, and then click continue. And then we're ready to run the analysis. So we'll click OK. Alright. Now if you look at this up here, what it's going to tell you is the number of participants in each different level of each of these separate independent variables. So for year, you've got the number, like the actual numerical value, but then the label. So you've got the Reagan years, Bush Sr., all the way to Obama. And one thing that you're probably going to notice is that we have the smallest sample size in the Bush Sr. years. And really, that's not a huge problem. The reason it's that way is because Bush Sr. was a one-term president. So we have essentially one election year for him, whereas all of these others are two-term presidents. If you look at region, you also see some discrepancy, and that's really just because there are different numbers of states in the different regions. So again, nothing of a huge issue there. Now we can look at the means for each of these different regions, each of these different combinations, and it's probably still going to be difficult to tell what's going on, mainly because you have 20 different conditions. So if you think about the factorial ANOVA, it's a 4 by 5 factorial ANOVA. 4 regions of the country, 5 different presidential terms. So, 5 different presidential tenures or whatever. So 20 different conditions. Now you can sort of see that there is some variability in Democratic percentage of the vote right here between these 4 regions. And if you wanted to look at the presidential terms, you would just look at the total here. So for Reagan years, the average is 39. For Bush Sr., it's 45. Go all the way down. Now to see if we have any effects, this is what we're going to look at. Now again, corrected model and intercept, those are things not necessarily of importance to us right now. Just like this r squared and adjusted r squared, we're going to get into that when we go into regression. The main things for us at this moment are the year quarter, the region, and then this year quarter by region. So anything with the asterisk denotes the interaction term. So these two are our main effects, and this is our interaction. So to see if we have anything, we're just going to go all the way over here. And we have a pretty large F value, a p-value of less than 0.001, and then a partial eta squared, so an effect size of 0.17. So there is a main effect. It seems that Democratic percentage of the vote varies as a function of year, or of presidential tenure. And that makes sense, because if you think about the presidents listed, there is some fluctuation. Some of them are Republicans, some of them are Democrats, and it should change. Otherwise, they wouldn't be elected president, right? Otherwise, it would just be one way. You would either have all Republicans or all Democrats. For region of the country, we scroll over and we can see that that's a larger F value. Again, P is less than 0.001. And although we can't really compare these, we can compare the effect sizes. So there is a greater effect of region on Democratic percentages of vote than there is on presidential tenure or year. Now if we look at the interaction, there's also an interaction. Now you can notice that the F value is small, but it's actually not a bad F value. P is less than 0.001. It's not like we have 2,000 data points. It is a fairly large sample size, but still, this is a pretty good effect for the type of data we're looking at. So we have two main effects and an interaction. Now the easiest way to figure out really what's going on is to scroll down here and look at this graph. So I'm going to try and make this larger. Don't know if it's going to work. Well, it's not going to work. Okay, so over here on the y-axis, this is Democratic percentage of the vote, and on the x-axis, this is presidential year. So again, to the left, these are the 1980s, and this is present day. So if we wanted to look at the main effect for a year quarter here, which we had, you can see where the effect is coming from. Basically, there is a linear trend, somewhat linear. We are getting, on average, over the course of time, we've increased the percentage of Democrat vote. So Democratic percentage of the vote for each of these elections seems to be increasing with time. Gradually here, and then a little more in this one region. But if you combined all of these lines, it's still going to be a slight upward trajectory. So that's where the main effect is coming from. If it was completely flat, you wouldn't really have any effect, but it's not. It's going up slightly. So that's where the main effect for year or for presidential term is coming in. Now, there's also a main effect for region, and you can also see that. These are pretty much the same, but you see this big difference right here. The Northeast, on average, tends to have a higher Democratic percentage of the vote than the rest of the country, just on average. It's a little closer over here, a little further away over here, but on average, it's a little bit higher Democratic percentage of the vote. If you want to think about this in other terms, the Northeast tends to vote in a more liberal direction than the rest of the country, and that's probably where the main effect is coming from. Now, we also have an interaction in our analysis, and you can see that in the figure as well. Now, the easiest way to look at this is if you think of all of these other regions as basically the same, which they are. They're sort of crossing each other at different points. They're not really separating out anywhere along the timeline. If you think about this as one line, and then the Northeast is another line, what's happening is back in the Reagan years, we have pretty similar rates of Democratic percentage of the vote. The Northeast is still larger, or a higher Democratic percentage of the vote than the rest of the country. Perhaps not statistically significant, but it's higher. And as we get closer and closer in time, they are separating from the rest of the country. So they're becoming more liberal at a faster rate, essentially, according to the data. Whereas we still have an increasing trend, it looks like, for the rest of the country, it's not happening as fast. So the slope of increase, that increase in Democratic percentage of the vote, is greater for the Northeast than it is for the rest of the country, and that's what's driving the interaction. At least it looks like that. So that's all I have for this video. In the next video, we're going to follow up and look at how to properly look at simple effects, something called probing the interaction, and we'll go over that in the next video.